What are lubricant specifications? Or more precisely, where do they come from? So if we take a step back, what we're trying to eliminate in general is stuff like pollutants. So lubricant specifications are largely driven by environmental factors. And who is the one who is driving these overarching goals? Well, generally, it's the government. Ooh, the government. So let's talk a little bit about the role of government and how that drives lubricant specifications, because the government is not reaching into the lubricants industry and fiddling around with like levels of ZDDP or anything. So how are they driving it? Well, you've got the government that is setting these overarching goals. It could be NOx emissions, particulate matter. The thing that is de rigueur at the moment would be CO2 emissions. And they are really giving direction to the vehicle OEMs. They're saying to the Fords, GMs, Toyotas of the world, you must reduce your emissions of X, again, NOx, particulate matter, and CO2, and it's up to you to figure out how to do that. Most of the time, the governments are technology agnostic. Now, increasingly, they're starting to be more, let's say, aggressive about EV adoption, and they're specifically pushing that technology. And I think that's personally a mistake. However, for the most part, they have been technology agnostic. And so it's up to the vehicle OEMs to then come up with some kind of stack of different technologies that is going to accomplish that. So in the past, for example, they've introduced things like DPFs, exhaust gas recirculation. They've made combustion more efficient inside the actual chamber itself. They've gone to direct injection. They've looked at stop-start. They've looked at hybrids. All of this stuff is in an effort to reduce emissions. Here's where that comes in, right? Then, at the bottom of the stack, we've got the lubricant manufacturers. So generally what happens is that the OEMs come up with some kind of technology stack, and then they turn to the lubricant manufacturers and say, get us an oil that is going to protect the engine that we have designed. So that's the challenge, right? We are very much in the lubricants industry at the bottom of the technology stack, in the sense that we get all of these technologies and these regulations handed down to us, and then we have to deal with it. Now, one thing that you'll have noticed if you've gone into any kind of store, whether it's an auto parts store or otherwise that sells lubricants, you'll have noticed that there's a lot of brands out there. And it would be challenging for all of these brands to go and do their own R&D completely independently. So this is where organizations like the API and ACEA come in. So API is the American Petroleum Institute. ACEA is, it's a French acronym, Automobile Confederation something, and they perform roughly the same role in Europe. Now, what they do is they come together and they set some, overarching guidelines for the industry, for the entire lubricants industry, that if they hit those targets, then it's going to enable us to meet the government regulations that were set out. So, let's say, for example, the fuel regulations would be Euro 5, Euro 6, that kind of thing. All right, so how does that affect things like lubricant formulation? All right, let's take one of the technologies that the OEMs have employed. Let's look at catalytic converters. Now, what's the purpose of a catalytic converter? Largely, it's to take NOx-style emissions, as well as things like carbon monoxide, and to convert them into less harmful molecules like nitrogen and carbon dioxide. Ironically, we think of carbon dioxide as being the big enemy at the moment, but carbon monoxide is way more toxic. So we'll take carbon dioxide where we can. All right, that's the purpose. Now, if you look under the hood of what a catalytic converter does, it has these kind of honeycomb structures. And the whole point of those is that they're embedded with all these rare earth stabilizers, and the honeycomb structure is designed to maximize the surface area. So those rare earths are what is interacting with the exhaust stream, and they're converting them into less harmful molecules. Now, here's the challenge. We have molecules that we've used since the 1940s, specifically the ZDDP family, right? These are full of highly active sulfur as well as phosphorus. Now, we like the fact that they're chemically active, or they're attracted to metal surfaces, because that's how they perform their anti-wear function, right? They see metal surfaces, they help form an anti-wear layer on all the surfaces of the engine. Now, that is a problem when it comes to catalytic converters, because if we have any sulfur and phosphorus in the exhaust stream, it tends to plate out on those rare earth catalysts, right? And now if I have a carbon monoxide molecule looking to interact with, let's say, for example, some platinum, it has nowhere to go, right? There's no free sites. And this is a process that we call catalyst fouling. Now, if you go upstream, right, of the catalytic converter, right, where does all of this stuff come from? Where does the sulfur and phosphorus come from? Well, if you go back into the engine, there's really only three things that go into an engine, right? There's fuel, there's air, and there's oil. Now, fuel as well as oil both contribute sulfur, but it's only the oil that really is contributing both sulfur and phosphorus. And it comes from ZDDP as well as some of the other different additives like molybdenum dithiocarbamates, right? Now, because we have a lot of phosphorus and sulfur in the formulations, and they are detrimental to catalytic converter performance, what the likes of ACEA and the API do is they start setting out rules where you can only have certain levels of sulfur and phosphorus, right? That stands to reason. Now, what are some of the other rules that we now need to set in place, because we always have these sort of unintended consequences? Well, if we reduce the amount of sulfur and phosphorus available, we're theoretically reducing the anti-wear protection of the oil. So, as a result, they need to set other different testing regimes which ensure that the lubricant manufacturers are not just pulling out all the anti-wear out of it, they're substituting that with something else which is going to continue to protect the engine. And that's where you get all these tests around things like, valve train wear or timing chain wear and all that kind of stuff, right? So that is the kind of the cycle which helps explain why API and ACEA set all of these different specifications. But now, what's the role of the OEMs? So why are the likes of Porsche or VW, why are they stepping into the fold and setting their own specifications? Well, just if you take a look at Porsche. Porsche sets, for example, its own specifications like A40, which is pretty much analogous to a ACEA A3B4. And then they've got the new C40, which I think was released in 2019, and that broadly maps onto the C4 spec. Now, why is it that Porsche feels the need to do this? I think there's two reasons. First of all, Porsche and VW and BMW and all the rest of the manufacturers may have specific requirements about their engine design that go above and beyond the API and the ACEA classifications, right? So they want specific testing that's performed on lubricants so they can make sure that they're going to be adequate for their engine technologies that they've employed. That's one reason. Now I'm going to put my tinfoil hat on and give you what I think is the other reason. I think the other reason that they do this is because they feel that that ACEA and API has kind of lost control of the process, right? When you look on the back of a lot of oil bottles that you buy in the store, they claim a lot of different specifications, and in some cases, it's impossible for them to do so. I see oils, locally here in Australia that are claiming A, B, C, D, E, F, G, H, I, J, K, all the way through to Z. Obviously, that's a euphemism, right? Not actually claiming that many because ACEA Z doesn't exist, but they're claiming a whole bunch of different competing ACEA claims which are mutually exclusive with each other. Sometimes they do it with OEM claims as well. And I think that the likes of the different OEMs feel that there's a lot of cowboys out there, right? Whereas if they control the process, so you have to submit an oil sample to them, they can test it, they can verify that it meets, for example, ACEA C4, as well as do a little bit of testing of their own, then they can verify and therefore put your name in the booklet to ensure that it meets their specific performance claims. If you found this content useful, head on over to lubrication.expert. It's a website where there's tons more training courses, they're more structured, and it's available for about $22 a month.